Hello, everybody, and welcome to Part 3 of the Dynamics 365 TechTalk Performance Testing Series. Today's topic is Considerations for Dataverse and Customer Engagement Apps. My name is David, and I'll be your moderator today. We're broadcasting this session through Teams live events, and the audio can be heard through your device speakers. This session is being recorded on behalf of the Microsoft Corporation. When you join this event, your name, email address, and/or phone number may be viewable by other session participants in the attendee list. By joining, you're agreeing to this experience. The recording will be available on the Tech Talks Community Dynamics page within 5 business days. If you have questions for the presenters or need support, please use the Q&A panel located on the right side of your screen. Our presenters will be responding to your questions during today's presentation and in a brief Q&A at the end. Thank you for your patience during these announcements. Presenting for us today from Microsoft, we have Zach Olson, Senior Program Manager, and Dave Burman, Senior Solutions Architect. Zach, over to you.
Thank you, David. In this session, we'll be discussing the performance testing considerations for Dataverse and customer engagement apps. Let's get started with a quick advertisement for the Dynamics 365 Success by Design Implementation Guide. This book has been written by fast-track solution architects, and it provides prescriptive guidance to implement and run a successful Dynamics 365 implementation. This is the third session of a series of tech talks dedicated to performance testing. Next up in the series is how to analyze and mitigate performance issues for finance and operations apps. This will be delivered on April 27th. The objectives of today's session are to provide recommended practices for planning and executing successful performance tests, to help define performance tests that will result in accurate and realistic performance metrics. What we won't cover today is guidance on specific tooling to execute performance tests. We won't talk about target baseline performance test metrics or how to analyze performance test results. We have a handful of topics to cover throughout the session. We'll start by looking back at some of the content that kicked off the series. Afterward, we will look at considerations that are specific to Dataverse and customer engagement apps. We'll cover environments, users, testing approaches, use cases, user load, transaction volume, and framework. These considerations are based on past experiences executing performance tests for customers or guiding customers through their own performance testing. First, we'll recap some of the points from the first Tech Talk in the series. What are we trying to achieve in performance testing? Performance testing is a key element of any successful implementation. It ensures that the solution enables the business to achieve its goals. If we're expecting our new app to handle 1,000 users on the first day, we do everything we can to make sure the solution scales appropriately before we go live. We measure response times at various user loads, identify any bottlenecks, make our optimizations, and then test again. Performance testing is iterative. We run tests, analyze results, make optimizations, and then test again. The goal is to go live with confidence. Customers often ask, why should we run performance tests? This is a cloud solution and it's Microsoft's responsibility. Microsoft is indeed fully committed to delivering a scalable platform in standard solutions. Dataverse and customer engagement apps are highly extendable. Configuration, customization, integrations, analytics, and reporting, if not done correctly, have the potential to negatively impact the performance of an application. This impact needs to be understood and managed to ensure performance remains acceptable. The on-premises mindset of fixing software problems with additional hardware is expensive and usually only a temporary fix. In some situations, additional hardware doesn't solve the issue because the solution design does not scale. For these reasons, it should be clear that it is the responsibility of the project team to deliver a well-performing solution. Performance is a shared responsibility between customer, implementation partner, and Microsoft. The customer owns the solution, describes business goals, and predicts transaction volumes. The customer also plans for performance testing and makes sure relevant resources are available for the testing. The implementation partner builds the solution, documents the customer processes, captures non-functional performance requirements, and builds a scalable solution. The implementation partner might also provide expertise and support for the performance testing execution. Microsoft manages the platform, ensures core platform components have sufficient resources, delivers solutions for performance issues within the Microsoft scope, and supports investigations into performance issues outside of the Microsoft scope. Now we'll talk about environment and user considerations as it relates to Dataverse and customer engagement apps. When it comes to environments, these points have been covered many times in the past. Performance testing needs to be isolated. A performance testing environment needs to be considered in the overall environment strategy, but what can often get overlooked is the impact performance testing has on capacity. Capacity is pooled across your tenant and shared among all environments and workloads. Performance tests create data that will consume your tenant's capacity. Usually, the data created by a performance test is only useful for a performance test. You should have a cleanup strategy to avoid overages that can block admin operations like, but not limited to, creating, copying, or restoring environments, or adding a Dataverse to an environment. Another area that might sometimes be an afterthought is the impact that role-based security has on performance. Your testing should be accurately based on your security model. It is possible that different security configurations will have different performance based on the amount of data that a user has access to. For example, in this scenario, user 1 might not have as good of performance on the account and contact tables as user 2. This is because user 2 needs no filtering on the account and contact tables, and user 1 does. Also, if there is a need to perform sharing in a test, you may see the gradual impact that high volume sharing has on performance. This may make you revisit the overall security strategy and come up with a different security model. Lastly, any test with the system administrator security role will always see better performance. The information returned to a user with the system administrator security role does not need any security filtering. These roles can be used to record and create tests, but should not be used when executing tests or assessing performance based on a persona. Next, we'll quickly cover the different approaches to performance testing. When we think of performance testing, we can broadly think of these 4 approaches: load testing, automation testing, batch testing, and manual testing. The load testing approach is to ensure functionality works at scale. This often happens when functional development is completed and prior to go live. You might also continue load testing as new significant functionality is introduced. This can be a regular occurrence, but less frequent than manual or automated functionality tests. For example, think spring and fall wave updates. Automated testing is a continuous process, possibly built from the outputs of manual test activities or from unit testing code. This testing occurs throughout the project and through regular build or release cycles. This can be integrated into your ALM automation strategy. This approach to testing is useful for detecting regressions in functionality or degraded performance of the end user's experience. Batch testing is typically performed in cutover or data migration scenarios. In these tests, there is an emphasis on throughput measurement rather than concurrent usage or responsiveness. It is an infrequent activity, for example, maximizing throughput of your data migration stream for a predictable cutover. And finally, manual testing. Manual testing is in-sprint testing as functionality is developed and signed off. This occurs throughout the project, but is not very scalable. Automation testing is often a product of this manual testing. Now we'll talk about the different use cases for performance testing Dataverse with a focus on load testing. When we think about a test case, this is an example of what a single test case might look like in a model-driven application. The test includes a number of steps that simulate user actions. Each step is a transaction that is an interaction the user has with the platform. These transactions can be described as navigation, searching for data, or updating or performing an update, just to name a few. The transactions themselves may be comprised of one or more requests to the service. It is important that these tests cover the primary use cases first. Each test should be end-to-end, including realistic navigation. Some test cases can be cumulative. For example, if test case 1 is to navigate, search, and update a record, and test case 2 is described as navigate, search, and create an activity for the same record, these tests can be cumulative. In a real-life situation, a user would not perform an action on a record, then start over to perform another action on the same record, or go back to a dashboard just to navigate back to the same list of records. Conversely, if volume is low, you might add extra tests to simulate additional traffic like navigation, searching, or opening records. However, you should not do anything in these extra test cases that would interfere with the primary test cases. In a performance test, you want to consider the entirety of the solution. Different personas will be interacting with the system at the same time, and this needs to be factored into your testing strategy. The Power Platform enables users to interact with the Dataverse through different no-code, low-code, or customer engagement apps. A mix of Canvas, model-driven, and Power App portals converging into one app is becoming more and more common. For example, someone making changes to a building might submit a request for a building permit through a Power Apps portal. A city user might use a model-driven app to review and approve or deny the permit. Meanwhile, an engineer might be performing an inspection and taking pictures of the property for the permit using a mobile or tablet Canvas app. All of these things will be happening at the same time. The bottom line, test it all, test it concurrently, and test it completely. Wherever possible, we encourage integrations that are triggered by Dataverse actions to be enabled. If volume is realistic, this can help ensure that integrations do not become a bottleneck and can keep up with the expected volume. Also consider that you are working with test data. We don't encourage sending load test data to production integration endpoints. For example, sending load test emails to a customer, validating fake addresses, or sending SMS messages to real customers during a load test. Additional considerations are the data sources that your applications read and write data from. Model-driven apps and portals ultimately hit Dataverse. They use the Dataverse or portal security models. They are also affected by service protection limits and entitlement limits that apply to Dataverse. Canvas apps might use the Dataverse connector or other connectors. They can be affected by service protection limits and entitlement limits that apply to Dataverse. They can also be affected by limits that are applied to other connectors. For example, the SQL Server connector has limits on the number of calls per user or the number of calls per connection. The specifics of each throttle or limitation are not important for this discussion. It is important to understand that the limits that apply to the connector or data source that your app is using. Now let's get into determining user load and transaction volume. This can be a controversial topic. It's important to know the real expected user load and transaction volume. You might capture this based on a legacy system. If this is a new app, it might also be based on licensing. The key is performance testing or load testing is not stress testing. We don't encourage or support stress testing. You are testing a shared environment. As we have mentioned in previously, there are service protection limits in place. These limits are there to prevent high volume scenarios like load testing from impacting the shared environment. We call these noisy neighbors. Testing is also iterative, so you can plan to run tests at various volumes. We suggest running a baseline test. This might be at 100 users. Then you can run a test at your expected load. Finally, 1.5 times your expected load. This is to help you understand how response times are impacted by an increase in load or volume. Running at higher than expected volume also helps ensure that the solution is reliable in the case of a spike in volume or higher than usual traffic. The total number of tests per user per hour realistically would not exceed 20, or 1 test per user every 3 minutes. This allows users to do certain things like have conversations with customers, respond to questions, have time to think, and refill their coffees. We'll see what this really looks like in a future slide. Drilling a little deeper into the service protection limits that apply to Dataverse, again, these limits are there to prevent high volume scenarios like load testing from impacting the shared environment. They ensure performance for all customers and don't cause performance issues. These limits are applied per user, per web server, and are measured in 3 ways. First, the number of requests in a 5-minute period, so 6,000 requests in 5 minutes. The second, combined execution time in a 5-minute period, so 20 minutes in a 5-minute period. Or third, the number of concurrent requests, which is 52. Exceeding any of these limits will cause subsequent requests by the user to fail with HTTP 429 errors. Usually, no support ticket is necessary if you hit these limits. Reevaluate the volume you are sending or review the architecture of the test. You might hit these limits if your volume is unrealistically high or have too little users in your pool of test users. You might also see this if you're testing for throughput and you are not removing the Azure Affinity cookie. Realistic versus unrealistic volume. These tables are meant to illustrate realistic versus unrealistic volume. This is based on 10 users in a system handling a lot of work on a day-by-day basis. The first column describes the scenario. This is what the user is doing. The second column describes how many total times each scenario occurs in a day. The third column divides the total volume per day by the number of users, in this case 10. The fourth column divides the amount of work per user by the number of hours in a workday, which is usually 8. We divide it by 8 so we know how many times a user will perform that scenario in an hour, because we want to run our tests for an hour. So in these tables, we're talking about a user's typical workday. They'll create some contacts, they'll update a contact, they'll have a phone call with a contact, and then they'll create a note for the phone call that they just had. The top table explains that a user is going to create 6.25 contacts in an hour, update 12.5 contacts in an hour, have 9.3 phone calls for those contacts in an hour, and for each of those phone calls, create a note. The bottom table describes significantly less amount of work. Collectively, the top table shows 10 users doing an unrealistic amount of work in an hour, and the bottom table shows 10 users doing a more realistic amount of work, but still a lot of work in an hour. Considerations for this are, how long does the phone call take? Or how many notes does a user take during and after the call? This is referred to in tests as think time. Let's take some time to talk about the framework for performance testing. This is a list of common tools used for performance testing. It is not an exhaustive list, and not each tool is used to test the same thing. For example, load runner, JMeter, or stress stimulus are used to simulate user load and user actions. Fiddler and F12 dev tools are used to inspect traffic and diagnose browser performance. Easy Repro is a Selenium-based tool used for automated testing, unit testing, and capturing end-user experience metrics. SQL Server Integration Services, the XRM Core Library, and Scribe can be used to generate large volumes of requests and interact with services. Last, and definitely not least, is Microsoft Premier Services Performance Benchmark Assessment. This is a service provided by Microsoft to execute load tests and provide results. The deliverable of this service is only the results. This is a typical path for projects that require performance testing but do not have the resources to do it themselves. Each of these tools serves a different purpose. Similarly, these tools show results differently. For example, load simulation tools run requests and transactions in a test sequentially and are not always an accurate representation of the end user's experience. Browser or end user-based tools like Easy Repro can use asynchronous patterns and are an accurate representation of the end user's experience. It's important to understand how to interpret the results or ask for help understanding what the results mean. From a setup perspective, isolate testing from any other work. Performance testing usually occurs around the same time as user acceptance testing. You want to consider that sample data created by performance tests can impact UAT. Development work may also impact performance testing. Solution deployments and publishing customizations will have an impact on test results and render a test execution useless. Test runtime is also a consideration. As we showed earlier, a test should run for no longer than an hour at peak load. Warm-up and cool-down periods are important. Warm-up periods are used to ramp up the test to the full user load and help the servers establish caching. Cool-down periods allow individual tests to complete if their run exceeds the 1 hour duration of the test. In a 1 hour test run, it is common to see tests with an increased user load yield better results than a baseline test. This is because tests with an increased user load generate more results for the test harness to sample. The load pattern you use can vary depending on the scenario that you're testing. There are two load patterns commonly used: constant load and step load. Constant load patterns are straightforward. A constant load test will run at a specific user load for a specific time frame, and the load does not change throughout the test. For example, 100 users for 1 hour. A step load pattern is different. Stepped load patterns will gradually ramp up user load to a specific count over a specified time frame. For example, start with 10 users, increase the user count by 10 users every 30 seconds until the test reaches a maximum user count of 200. Then the test will run at 200 users for the remaining duration of the test. Step load patterns don't use a warm-up, but the steps themselves can be considered a warm-up. Considerations to test patterns are based on the scenario. If you anticipate 1,000 users to access the application, a constant load pattern will submit the first 1,000 requests as fast as possible. This might not happen in real life or be realistic, and you may see issues. This can be mitigated with an appropriate warm-up period or a step load pattern. This illustrates the use of F12 browser tools to inspect a request to create a record. In your test, you will likely have to use the details from a record you created in subsequent requests to update or associate data. When you click Save in the command bar, a post is sent to the service with the necessary details to create the record. The service responds with a success and includes a location header in the response. The location header value has the API URL to retrieve the record you created, including your new records GUID. You can correlate the location header's value to subsequent requests that need to work with the record you just created. The next illustration shows where your extracted value will be used to update the record you created in a previous transaction. A JSON body with the values you are updating are sent in a patch to the service. Only the information being updated is formatted in the JSON. In this example, we are setting the primary contact, the website URL, and the ticker symbol. This is a generic example of where to extract or pass values when creating or updated records. You can apply these concepts to any of your scenarios using the load test tool of your choice. Finally, we'll cover some best practices. This is often missed. In load testing, test results are based on response times to the machine hosting your tests. If you are hosting a test in Europe and your environment is in North America, the latency between the continents will have an impact on your test results. Consider hosting your tests as close as you can to your environment. If the resources are available, leverage Azure VMs to host tests in the region nearest your load test environment. Some additional best practices. 1, let Microsoft know. If you encounter issues during the test that you believe to be related to Microsoft infrastructure, you can open a support ticket, or you can engage your designated support engineer or customer engineer if you are working with one. The load testing environment should have production-like customizations, configuration, and sample data. It is up to the customer and partner to have this set up. Environments that are not configured as close to production as possible in terms of data, table size, and customizations or configuration, including integrations, will not have the same results as go live. Remove any requests for static content from your tests. Files like JavaScript, CSS, images. Caching only happens the first time a browser hits a page. It is not real life or realistic to include this content in your tests. Cold or non-cache content will dramatically increase the transaction times in your test results. Use a pool of test users. Configure test users to execute tests based on a security role or persona for the most accurate results. Different security configuration will have different performance, and using a system admin for load testing is not recommended. If you can, use Azure virtual machines to host tests. Use Azure regions closest to the environment, for example, East Coast, West Coast, different countries. Whatever you can do to have the lowest latency, not dependent on local networks, VPNs, or desktop configurations. Lastly, be realistic. Load testing is not stress testing. Stress testing is not supported in a shared environment. User volumes should be kept at less than or equal to 20 tests per user per hour. And now we can open it up to some Q&A.
Thank you, Zach. So it's been a bit quiet on the Q&A front so far. We've had a question around how Dataverse environments are sized based on load and whether they vary based on usage. And I've put a link in the chat to a recent video from our colleagues in the PowerCat team who recently interviewed Sri from the infrastructure team, who went into great detail about kind of how we size our environments and how they're scaled out. And so on and so forth. There's nothing, documented on that specifically in terms of, the standards that we provide, and it's part of the kind of evolving managed service that we have in that we're constantly monitoring and improving on that. But the video there will give you some really good guidance there.
Yes,
we've also. Yeah, sorry. We've also had a question around what tooling we recommend. Is that one you want to cover, Zach, or do you want me to take that?
I think we can both cover it. Why don't you go first, and then I'll share my opinions on that next.
Yeah, sure. I mean, so just to reiterate the start of the deck, really, that we specifically called out that this wasn't really in scope for today's tech talk. We are aware that there's, a number of different performance testing tools available out there on the market. And in terms of Microsoft provided ones, there's not a strong story there at the moment. And so it really is just a case of evaluating the tools that are out there and picking the ones that closest meet your needs. We don't specifically recommend any particular tool over any other tool. And I just encourage people to do the research and understand what their requirements are and pick the right tool accordingly. Zach?
Yep, I agree 100%. And I would say if there's a tool that is used to do any one of these things that you're trying to test, use what you're most comfortable with. Obviously, some tools offer a little bit more than others in terms of integration or connectors. But in terms of a tool specifically, we're not going to have a specific recommendation. So if there's a tool that your company or your implementation partner has standardized on, in most cases, that tool is probably going to be okay. I think, too, you can take it a step further and use a combination of tools. There's a peer on my team that explains this really well about having a macro focus and a micro focus on automation testing. And the macro focus on automation testing is using some type of tool to simulate user load and user actions on the service. A lot of times, in almost every time, that's not going to be an accurate representation of the end user's experience, which brings you to a micro focus on performance, which is either while a load simulation test is running, a micro focus would be to manually test your scenarios in the environment that's being load tested against. Or if you have a Selenium-based or automation-based type of tests coded to run against your environment at the same time, then to run that micro test at the same time as your macro test. So that way you get the load simulation in the response time metrics, and then also can capture what the end user experience will actually be, or as close to it as possible.
Great. Okay. And then in one final question in the chat is, are there any sample scripts for load testing based on standard Dynamics 365 HR/CE? So I'm not aware of any in this space. Zach, have you got any thoughts on that?
I do have some thoughts, and there's not going to be a sample script per se. And the reason that there's not going to be a sample script is because every page, every form, navigation, etc., is all going to be different. If I load a page, an account page or an account form, and David loads an account form from a different environment, my page could have 100 requests executed through JavaScript, or could be impacted by maybe some other server-side code, and David's might be 100% vanilla and look much better. So we lean on customers to assess and create them themselves, and if they have trouble too, then they can reach out to the community for assistance on creating a script that best suits their scenario.
Perfect. Okay. So there's no other questions in the chat. Suggest maybe we look at wrapping things up.
That sounds great to me. If there's no other questions, then David, back to you.
All right. Well, thank you very much, Zach, and thank you, Dave. I've posted a link to a short survey in the Q&A panel, and we'd like your feedback on today's session and hear what you'd like to see in future events. Thank you for your participation. As a reminder, the recording of today's session will be available on the TechTalks Community Dynamics page within 5 business days. I'd like to extend a big thank you to our presenters and audience for joining us today.